This is our home. It goes by various names: Silver River, Spirit Road, Winter Street. The Romans thought of it as a road traveled by the gods and named it Via Lactea, or Milky Way. This was an adaptation from the Greeks, who called it Kuklos Galaxias, or Milky Circle. The first thing I want you to do is just admire it. Our ancestors have done so for countless generations. It contains over 100 billion stars, although you can only see some of them individually by eye. Most of them are so distant that their light blends together to form a white streak across the sky. As beautiful as this image is, our view of the Milky Way is unfortunately limited because we're stuck inside of it. Kind of like how it's difficult to appreciate the Earth as a whole when we're stuck on its surface. But we can look at other galaxies that are similar to the Milky Way. This is our sister galaxy, Andromeda. If we could see the Milky Way from the outside, it would look similar to this. An ordered disk of 100 billion stars, all orbiting about the galactic center once every 200 million years. This means the last time our star, the Sun, was at its current location in the galaxy, the dinosaurs ruled the Earth. Coming back to our Milky Way galaxy. As we look at it, a question immediately comes to mind. How did it come into being? I like to think of generations of humans who've looked up at the night sky and wondered this. I imagine they also wondered, how old is it? Did it always look this way? What is its origin story? And how does this relate to our origin story? In Greek mythology, the Milky Circle was created when Heracles, also known as Hercules, was flung from the breast of Hera, leading to spilt milk. Many cultures articulate an origin story with a chaotic event like this, like the spilling of milk, or the flinging of food, or the sprinkling of seeds that led to the creation of a beautifully ordered disk galaxy as we see today. Therefore, many ancient ideas of the origin story reflect this idea: out of chaos comes order. Of course, these ancient ideas to explain the origin of our Milky Way are, in detail, incorrect. But an exciting thing I want to share with you today is that we now know the answer to this question: how our galaxy formed. This is thanks, in part, to advances in supercomputers and our ability to use them to model the complex physical processes involved in how a galaxy like our Milky Way formed. And one of the things we find is surprising: that this ancient idea, common to many origin stories, out of chaos comes order, is in fact correct. Our Milky Way, highly ordered today, was forged in chaos. My name is Andrew Wetzel. I'm a professor of physics and astronomy here at UC Davis. I am a theoretical astrophysicist. When you hear that, you probably think I do a lot of this. And while I do that, most theoretical astrophysics today is computational. So it looks more like this. In particular, I take the laws of physics, translate them to computer code, upload that code onto the world's most powerful supercomputers, and use that to generate models that describe the full formation histories of galaxies like our Milky Way galaxy. Now, when I first say astrophysics to you, what you probably think is what many of my observational astronomy colleagues do, which is use telescopes to make beautiful images like these. And indeed, much of our knowledge of galaxies comes from these amazing telescope images. However, they're limited. Here's the issue. Galaxies form and evolve across the full formation history of the universe, across 13.8 billion years. It takes a galaxy 1 billion years to change appreciably. So these images represent mere snapshots in time of a full life of a galaxy. Think about trying to understand the full life of a person based on just a single picture of them. Difficult. And this is a big challenge in astronomy, but computer simulations now allow us to see how a galaxy would look across its full formation history, across billions of years. Let me show you. This movie shows the evolution of our Milky Way galaxy over the last billion years. This is one of the simulations that I've created. And as we fly through, it'll help you get better perspective of how our galaxy would look both from the outside and from the inside as we see it. Next, I want to say a little bit more about the astrophysics that goes into these computer simulations. What are the ingredients required to make a galaxy like our Milky Way? Well, the two most important ingredients that we see in a galaxy are hydrogen gas and stars. Next, we need the laws of physics, the algorithms that govern the evolution of these ingredients. The most important of which, by far, is gravity. It pulls everything together. If I jump up on this stage, I come back down because gravity pulls me back to the Earth. The same is true of hydrogen gas in a galaxy. You see, when galaxies first formed, most of the normal matter in them was just hydrogen gas. Stars, like our sun, only formed later when gravity caused that hydrogen gas to collapse and reach high enough densities to form stars, as you can see in this beautiful telescope image. Galaxies are basically just factories for converting hydrogen gas into stars. Now, this is where things get complicated, because star formation in a galaxy is a feedback loop. What I mean by that is gravity causes hydrogen gas to collapse to high density to form stars, but at the end of their lives, many stars explode in fantastic events we call supernovae. And these supernova explosions push back on the hydrogen gas around them. Here's what a single supernova event would look like. These supernova explosions occur rarely in the Milky Way, about once per century, at least in the Milky Way's recent history. When they do occur, they can be bright enough to see even during the daytime, as our ancestors have recorded. This image shows a depiction of supernova 1054 that occurred almost 1,000 years ago. And what we now appreciate is that these supernova, these thermonuclear bombs, these agents of chaos, are vitally important in shaping the histories of galaxies like our Milky Way. So with the ingredients in place, I now want to show you one of my supercomputer simulations that depicts the full formation history of our Milky Way galaxy. On the left, you see the hydrogen gas, and on the right, you see the stars that form from the gravitational collapse of that hydrogen gas. Let's watch that again more slowly, and what I want you to focus on is first chaos, then order. Early on, the Milky Way wasn't just a single galaxy, it was many tiny galaxies. But gravity pulled them together as they grew bigger over time to form one single Milky Way. Think about many cars trying to enter an intersection all at the same time from random directions. Chaos. Furthermore, early on in the universe was much denser. As a result, the rate of hydrogen gas falling into the Milky Way was much higher. The rate of stars forming in the Milky Way was much higher. And therefore, the rate of these supernova explosions was much higher. And remember the feedback loop. Gravity causes hydrogen gas to collapse and form stars. And then after the stars form, many of them explode in supernova that push the hydrogen gas back out in a chaotic fashion. And you can see as the gas comes out of this Milky Way. But as billions of years progress, something remarkable happens. Out of chaos comes order. As the universe continues to expand, the rate of galaxies falling into the Milky Way goes down. The rate of hydrogen gas falling into the Milky Way goes down. The rate of new stars forming goes down. And the rate of supernova explosions goes down. As a result, our Milky Way was able to settle into a long-lived, stable, ordered disk as we see it today. Now, perhaps you're thinking, that's a nice simulation model and a nice movie, but what does it have to do with me? Us. Well, this story has everything to do with us. You see, the Earth and the Sun formed 4.5 billion years ago, after the Milky Way settled into its ordered state, when chaotic events like supernova explosions were relatively rare. Remember, supernova are like thermonuclear bombs going off in the galaxy. Frequent supernova events in the early chaotic phase were not conducive to the emergence of life. By contrast, the late, stable, ordered Milky Way was conducive to life. Therefore, our origin story is intimately connected to the origin story of our galaxy, the Milky Way. Finally now, I want to leave you with one important irony in this whole story. As I said, in the early chaotic phase of the Milky Way, frequent supernova explosions likely impeded the emergence of life. But ultimately, supernova promoted life in our galaxy. What do I mean by this? You see, when supernova explode, they create most of the key elements needed for life, including carbon, oxygen, iron. Think about it. Right now, the oxygen you're breathing was created in a supernova explosion. In the early chaotic phase of the Milky Way, these frequent supernova explosions not only created these key elements for life, but they sprinkled them across the galaxy. They sprinkled these seeds of life across the galaxy, similar to many of our ancestors' origin stories. Out of chaos comes order. Thank you.